systematic reviews and meta-analyses in behavioral ecology and evolution. And I tried my very best to make all of this work open, transparent, and reproducible as much as possible. And I consider open science as a very central to all of my work. And I'm also interested in understanding how we do research and in understanding how we can make it a little bit better. And uh, Alfredo, maybe you want to introduce yourself.
Yeah, so my name is Alfredo. I'm a PI here in Coimbra in Portugal. I recently moved to join the meta research group here, led by Tracy Weisgerberger. And yeah, I'm from the evolutionary ecology field. I've been doing meta-analysis now for around 8 years, and combining that with some empirical work and also a lot of meta research. And yeah, my interest generally are focused on doing really robust, reliable, and open and transparent science, and that applies, of course, to evidence synthesis and meta-analysis more specifically. So I think with that, Shreya, all yours.
Okay. And from what I understand, today we have a little bit of a mixed group in the audience from different career stages and research field. And this is very exciting. And even though some of the literature that I have cited here is from ecology, evolution, and environmental sciences, I think this is also broadly applicable to animal sciences and biomedicine. And also, you can refer to the parallel literature should it exist specifically for your field. And there are different guidelines that you can use that are more specific for your field. And I do know that they do exist for biomedicine, for example. And let us first begin with looking at what exactly evidence synthesis is. And to simply define it, what we want to do is to bring together information from different sources, often from published articles and reports, and sometimes also from different adjacent disciplines, and be able to have evidence informed discussions about this and be able to form certain decisions and even policies on certain issues. So it is to say a process by which we are gathering the evidence, we are assessing this evidence, and then we are combining this evidence to form a report or a published article. And there are several types of evidence synthesis methods one could use. There is narrative reviews, scoping reviews, and two specific ones that we will be discussing today, that is systematic review and meta-analyses. And I will not go into details of the different types of evidence synthesis that exist. Should you be interested in it, there will be another session right after the session at 4:30 that would cover these different types of reviews in more detail, along with best practices and AI use in evidence synthesis. And I would recommend you check that out if you're interested in it. And to define what a literature review is, that is the process of conducting surveys or of previously published material. And this can include empirical findings and methods and theories. And the goal is to integrate and critically analyze this literature and identify issue. And oftentimes, narrative or literature reviews could have a neutral representation, but more likely they have an espousal of a position where the reviewers accumulate and synthesize this literature to demonstrate the particular point that they are trying to make through evidence. So there is a stance that they are trying to espouse. And this can any kind of literature review, also including non-comprehensible, repeatable, non-repeatable, and non-systematically done systematic reviews could also have these biases. But to highlight some of them, these literature reviews could have lack of transparency, so that the methods that are used in narrative reviews are not reported in sufficient details. We do not know where this literature is coming from. There could be also selective bias or cherry picking, which is more common, where the Studies that are included in these reviews are selected based on what the reviewer is aware of, and not necessarily through a more systematic or comprehensive way. And another bias that could exist even in uh, in systematic literature review is language bias, where we do not search, or we are less likely to be able to include different studies that are from non-English research. And to show an example, this is a paper by Tatsuya Amano, and they look through 75,000 or so scientific documents on Google Scholar in the field of biodiversity conservation. And what they find is about 35% of this literature is in non-English language. So only about 65 or so is published in English. And should this be so? That basically highlighting that a large part of literature in some fields could be in languages that is not English. And where this becomes a problem is in this paper by Hannah et al. They show that of the 72 reviews that they assessed, only 44% of these reviews conducted a search that included terms that were in non-English language. So very often we do not include terms in our searches that can access the literature that is published in non-English language. So many other forms of biases can also exist, even in systematic reviews. That could be lack of consistency, and in screening process, even in data extraction process, and many more. You could look at this paper to go through different kinds of biases that they talk about and certain strategies that they recommend that can help in avoiding these biases. Anyway, so for what makes a systematic review different is that it uses methods that are transparent, comprehensive, and objective to access this literature and then synthesize the evidence. And the goal of a systematic review is to provide a valid summary it is a summary of the primary research that is conducted. And ideally, it should be pre-planned and even pre-registered. And these procedures are explicit and also transparent and reproducible, or should be so. And even though we try to be as comprehensive in our search as possible, it is not always possible to synthesize all the literature that might exist in your search or in your field. And in these cases, sometimes it is more important to make sure that the sample of the studies that you are synthesizing is very representative of the research finding in your field, even though it might not be completely comprehensive. So, one thing that I will begin by saying that one must read the reporting guidelines and certain articles. And here I have highlighted a practical guideline, Cochrane Handbook, for example, PRISMA extension that exists for ecology and evolution, but there's also PRISMA guidelines in biomedical field. And these reporting guidelines are not just for reporting to be read and reported afterwards, but one should start a systematic review before. Should start a systematic review and read these guidelines before. So they are aware of what needs to be reported and what would be the most important things to keep note of as you go through the process of conducting a systematic review. Right. So, how do we exactly do this thing? There are certain steps. You would formulate a question. You would develop a protocol. There are certain search that you would do across multiple sources of evidence. You would screen for the evidence, you would extract the data, critical appraisal, which is also very important and more oftenly done in biomedicine. The risk of bias assessment as well is done more often in biomedicine, very rarely in the field of ecology and evolution. And I have not covered that today, but this is also something very important. And then you would extract data and form your synthesis and document all the activities in a detailed manner. However, I would flip this thing way around and say that one should think of all the things that they have to document and have a detailed notes and information on what they want to report later on as the first step. So I would recommend the step 8 is the step 0, even before is something you should think about even before you start your systematic review. Right, and then oftentimes we have certain steps that we would go back and forth with, such as searching across multiple sources, and then you could, after you find what in the search, what you find, you could also then go back and reformulate the question and so on. So it is a little bit of a back and forth process and not necessarily a very linear one. And don't be fooled by that. It being a very linear process, and steps of the systematic search are oftentimes very much laden with subjectivity, and a lot of decisions are made in the process. And there are several tools to minimize subjectivity and increase observant agreements like decision trees for screening, etc. And one should be very transparent and detailed in the report of. And before you commit to doing a complete systematic review, you should always keep in mind piloting the process beforehand. Right. And for doing a systematic review, I really like this illustration from Fu et al., which has different steps that this paper covers in great detail. So just like how you would decide on a review question, executing the search and initial screening, and the full text screening. Largely, these are the 4 steps that you would most likely conduct, and what most of the times they are assumed to be very linear. However, that is very rarely the case. Each step has several iterative processes, and sometimes you also go back and forth in these processes, and part of it would also be more likely to be in a pilot study, that you would do part of it and then go back and repeat the whole process once you have refined it for your entire systematic review. So keeping the expectations for how the process can go realistic also then helps us decide how long such a study would take, and to do it more rigorously and robustly. And I really like also this illustration from Jensen's book, where they show little blobs of sweat that go into different steps. And in some situations, so you can see these little drop marks that are there. And in some situations where I have also done this for myself, I would agree or disagree and add more droplets there. That said, there are also some tools that are very good, such as Predictor, for helping you decide how long systematic review could take, and you can enter different values in it. And I would like to show you the default values that they have here, which I felt I quite largely agree with. And they have these default values that are provided by assessment of 5 years of systematic reviews that are published in CEE, Collaboration of Environmental Sciences. And users have entered these values, and of course, you can also adjust them. So my overall point being that it is very helpful to keep the expectations more realistic to ensure that you have enough time and resources to conduct a systematic review in the most transparent and robust way. Right. And how do we decide on a review question? There are certain frameworks that are already proposed that one could use for different fields. So there is PICO-PECO framework, which are used in clinical experiments very often. And there are also sometimes these might not be directly applicable for your field or the kind of question you want to address. And in those cases, there are also adaptation like the PECO or the PO, which has like population, and you just have to think about the population and the outcome and then form the question related to that. And there's there's this website from the University of Australia, CQ, where they have different questions that you can look at, and they ask you specific questions for what your population is, what kind of intervention is. And going through these kind of frameworks can be very helpful in refining your question because having a very well formulated question in the start of a systematic review could be very helpful for setting the scope of the review and then deciding on to the search and the strategy that you would use to address this kind of a question. Right. And then you would go through several repetitive rounds of broadening the scope of your question and narrowing the scope of your question. And this is a very often the process that you have to adjust these steps a little bit and then also pilot the search and the 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 extraction of the data, etc. And then you would go on, once you have a defined question, you would go on to the search for the literature. And oftentimes, in developing this search string, there are certain things that can be very helpful. One is the use of your own personal library, the kind of papers that you think would be very relevant in this specific field that you're trying to do the systematic review on. You can also have some reviews or important empirical work that you can look into that would be very useful for guiding the development of the search string. And there's also something that we do, which is forward search or a backward search, which is to look for using this key or important papers, using citations to see what papers have cited this reference or this key paper, and also backwards search that what papers are being cited by this key or important paper that you have. And there are also certain packages and also a Shiny app that is developed for doing such kind of backward and forward search. It is called Citation Chaser. And this is also very helpful in trying to get a good idea of what kind of literature you would be looking at before you do the search. Uh, and also, developing some word clouds can be very helpful for developing the search string. So, in the literature, you would try to plot the different words that exist in your literature that can be very useful or important for finding the more keywords for your search string, so to say. Yes, and then one should ideally look at several databases and not just one. What kind of databases exist for different fields? There is Web of Science, Scopus, and many more that are there for biomedicine. There is also PubMed, and of course, there's also Google Scholar. And you can also try to search for gray literature, which is the unpublished data or thesis or reports that are not in any journal. And there are also preprint servers that you could look at. Of all of these, I would like to highlight a little bit about Google Scholar. Oftentimes, when you search at Google Scholar, there are certain drawbacks in it. The recall is very high, and the precision for Google Scholar can be very low. That is, you would find many articles on Google Scholar that are oftentimes not very relevant to the topic that you're searching for. And there would be the search string that we use for Google Scholar. There is a very low transparency as to how Google Scholar accesses this literature, so we don't know. And we also don't know if it is always reproducible. There are no Boolean operators and wildcards that work for Google Scholar, and also it is very hard to then download this search that you have conducted. Right. I will skip a little bit and go to a few. So when you design this kind of a search, there are certain operators that you could use, uh, such as and or not or near, where and is used for when both the words that you put before and after and, they have to be both true, such as or, where one of them should be true, and etc. And also you can use some wildcards, like asterisk that includes any characters, or question mark that includes only single characters, etc. And I will show you just an example of it. So here, when I look at the search string, I have two words that I'm using or I'm combining with and at the moment they don't have any wildcard. So what the search does is it has the word green and it has the word nest. So, wait, yeah. So I search for the word green and for the word nest, and experiment or manipulation. So if either of the word experiment or manipulation exist in it, the article will be included. And if the word, along with that, the word green and nest must be included. And when I conduct this search, 64 results are found. However, when I use this wildcard operator like asterisk, which means that it could then also include words like greenery, green with an S, or green with a dash and another word joined to it. Such words would also then be included. So when I don't use this asterisk, the search explicitly look for words like green and nothing after it at all. So this really can change the results that you yield from the search. And what I want to highlight then is that designing these search strings is a very should be done very carefully, and one should be very aware of what they are exactly looking for. And these Boolean operators and wildcard information should also be taken in account. Another thing that can be very useful is to plot some kind of network maps to see in this literature or this pilot literature that you have, to see what other words could be useful in including. So, for example, if I have only included the word green or green, and I want to also still be able to access certain literature that could be used, that papers could be using the word aromatic or herbs, etc. These should also be included. So plotting these kind of literature map can help us find some synonyms or similar words for different keywords that we are using within the literature that is being published. Right. And when I include words like green or aromatic, suddenly then my search results are much higher. And sometimes when you develop these search strings, they can go and explode into being very large search string. So I think this is also from the same paper, and this was the final search string that we then used. And therefore, I would also like to highlight that reporting this information should be done very carefully, so you can very easily uh, uh, truncate the search that you have reported versus what you had actually used. So if you were not to carefully include this information somewhere, it could be very hard to later on then be able to reproduce it very clearly. And just to show you an example of this, there was a meta research study where they looked at 100 systematic review in I think this is from medical sciences, and they could only fully reproduce the search for 1% of the study, and uh, 4.9% of the searches that were reported had all these essential items of PRISMA reported clearly. And what I'm trying to say is that most basic details like databases that are being used, the dates of when the search is being conducted, the kind of limits that we are using in these search string can be completely lost and not be reported clearly. And this can lead to large discrepancies between what the search was reported as and trying to reproduce the results, and making very reproducible systematic reviews difficult. Right. And yes, and then I wanted to just highlight that when you're exporting these files, you should try to export them with the maximum amount of information so that later, should you change a decision to include any of these information about the authors, the journals, these are all the traits that you can change in the search that you're conducting, in the file that you're downloading from the searches, and you should try to be mindful of anything that you might need later on. Right. And why in the start I said that one should try to access across multiple databases, and there can be different overlap between the databases. And this figure from Martin from 2018 show that the overlap between Scopus in Web of Science is rather better, but for Google Scholar, it can miss out some relevant literature, but also include a lot more literature that might or might not be relevant. And then you would download these search files. And the next step that then one would need to do is to screen the evidence for relevance to be included in your systematic review. And this kind of screening should be done with a predefined decision tree, ideally very clearly thought, and one should think about the inclusion and exclusion criteria that they are going to use for conducting such a screening, and keeping the research question very central to the design of it. So this is just an example of such a decision tree. And I will, where you can do certain screening. This is just an example of the kind of things that you could use to do the screening. There is RevTools package, which is usable in R. There is MedScreen Shiny app that is usable online on a web browser. And then there is also Ryan software, which is very commonly used, and it can also be used over the web browser. So these are just example of the UI of these. And what I wanted to show you here was that uh, so this paper from Schwanz showed that in the articles, the authors are trying to show that the systematic reviews from the search typically from these 29 meta-analyses that they look at, about 91% of the studies are oftentimes excluded or disregarded during the screening process, and only about 8.4 or so were ultimately included. So this is very normal and also something that oftentimes I've seen in the meta-analyses that I have been a part of. So for the full text screening, you would also do the same thing. You would have the decision tree, but for how to do it, that I'm not very aware of any software that exists for it. So we usually do it through using Zotero and manually downloading all the literature, and then making these decisions on the Excel. So should you have gone through the pilot process of this, you should ideally pre-register your study before you go ahead. And this helps in promoting the transparency and also reducing the potential biases that could come. So if you were to change certain decisions later on, this would be more transparent and clear in the process. And I think it is much more common in biomedicine to have pre-registered study. So I think it is required, if I'm not wrong. But for other fields, oftentimes this is optional, and I think it should be highly encouraged to pre-registered systematic reviews and meta-analyses. And these are just some examples of where one could pre-register their study. So Prospero is for medicine, and OSF is something that we very commonly use. Right. And nonetheless, I was talking about these decision trees, and it is very important to follow such kind of trees because these are certain subjective decisions. Should we not have a very guided protocol, step by step, as to whether to include a study or to exclude a study based on certain decision? There can be a lot of subjective decision that can be made, and people oftentimes disagree, or the decisions can vary between individuals. So, for the sake of consistency in the screening process and even in data extraction process, it can be very helpful to have a clear protocol to follow. And should there be enough quantitative data to synthesize from all these screening and search and everything that you've done? When you come with the final data set, if you decide that there is enough quantitative data that can be synthesized, it would be you are more likely or able to do a meta-analysis, which Alfredo will talk about in some time. And if that is not the case, which can also happen, that from the studies that you end up with, you do not have enough quantitative data, you have certain other choices to go back at, and you could do systematic maps and bibliographic analyses, and these decisions are oftentimes made on the basis of what is the scope of your question, whether what is the aim, and also practical consideration of how much time you have and what is the heterogeneity between studies. And just to show you an example from this paper, Nakagawa et al., they show an example of what systematic maps and bibliographic webs can look like. So bibliographic webs would be a relation between what authors are publishing on a topic and who is like what kind of citations are there in on this topic. Over, you can also have some spatial map where these topics are being studied. You can look at the phylogeny. So in different in our fields of ecology and evolution, it can be also interesting to look at different animals that are being studied and so on. So that can be very interesting to do. And these are also some other examples. This is an example of a bibliographic map where what researchers are studying these topics and how they are connected. And this can like also be very useful to look at gaps that might exist in the literature. So, any species that is not being studied for a particular question, or certain methods that are not being used, or should they be? So, you can get a very good insight into a field to look at it, even though meta analyses might not be possible. So, I think my overall concluding thing is to say that whatever you decide whether to do meta-analyses or a systematic map or bibliometrics, should you go through the process of systematic review, always document them well and try to follow some kind of reporting guideline to report them as best as possible. And yes, I think with that, I would like to conclude, and I hope I did not rush it too fast. Yeah.